Hello class, this is Mrs. Groves and we are covering section 9.1 and I'm going to be separating this lesson into two parts. 9.1 we have already gone over, and it is about type 1 and type 2 errors and calculating p-values. And so what I'd like you to do is to do section A, which is this first page, as well as the beginning of the next page. And then come back and watch this video, because this should be a review. But some students have been having a difficult time with these concepts. And because of that, I want to give a little bit more instruction in helping you understand some of these concepts about type 1 and type 2 errors, and they will definitely be on your AP exam. So the first thing I want you to do is test yourself and see if you can fill in this box. Okay, this is the truth about the population. Okay, so here the null hypothesis is true. Here the null hypothesis is false. If the null hypothesis is false, that means that the alternative hypothesis is true. Then you make a decision. Do you reject the null hypothesis or fail to reject the null hypothesis? And the questions are, this is alpha. How are alpha and beta related? How are beta and power related? Significance level. Which of these terms is equivalent to the significance level? So take a moment and pause the video and do those problems. All right, let's see how you did. So, when we reject the null hypothesis and the null hypothesis is true, that is a type 1 error. And a type 1 error is alpha. When we fail to reject the null hypothesis, when the null hypothesis is false, and you can think of this as a double negative, and here it's kind of like a double positive. Right? You fail to reject the null hypothesis when the alternative hypothesis is true. Also stated the null hypothesis is false. This is a type 2 error. Right? And a type 2 error is beta. And those are the two that we've already covered. Now these two are correct decisions. If we fail to reject the null hypothesis and the null hypothesis is true, we've made a correct decision. Great. That's equivalent to we find someone not guilty and they really are not guilty. Here, we reject the null hypothesis when the alternative hypothesis is true. That's also a correct decision. Okay? And that is going to be called power. and power is 1 minus beta. So the question is here, how are alpha and beta? Alpha and beta are related. They are related inversely. So if you increase alpha, then beta goes down. So alpha and beta are inversely related. And if you increase alpha, then power goes up. So alpha and power are going in the same direction. Well, how are beta and power related? Well, power is 1 minus beta. And you can think of it this way, that these two have to add to 1. So now the significance level is equivalent to what? Well, the significance level is equivalent to a type 1 error and alpha. All right. So now what I'd like you to do is I want you to read this problem, and I want you to go through and decide how to write a type 1 error and a type 2 error. Now, a couple of key things, and you have to find the best way for you to express it. For a type 1 error, one option is say, okay, we rejected the null hypothesis when the null hypothesis is true. Or some people like to do it the opposite. The null hypothesis is true, but we made the wrong decision. Okay? Well, you're just swapping those two. Whichever works for you. Here, describe a type 2 error. Well, a type 2 error, okay, is that you fail to reject the null hypothesis when the alternative hypothesis is true or the null hypothesis is false. The alternative hypothesis, okay, so for the option 2 is the alternative hypothesis is true, but you made the wrong decision. All right. So what I'd like you to do is go through and read this problem and see if you can write the answer for the type 1 error. Okay? And you always have to discuss the consequence. How does the consequence, okay, and this is usually a financial consequence, impact a type 1 error and a type 2 error? So pause the video and you can do the problem, and then come back and I'm going to go over the problem. So welcome back. Okay, to familiarize myself with this problem, I'm going to read it to myself again. Faster fast food. The manager of a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait to receive their food once their order was placed. Based on store records, 63% of the customers had to wait when they got to the cashier's window to reduce this wait time proportion. The manager assigns an additional employee to assist with the drive-through orders. Okay. During the next month, the manager will collect a random sample of drive-through times. Okay. So the store records say that 63% of customers have to wait 2 minutes. All right, so that's our null hypothesis. And he added a new employee to hope that he's going to reduce their wait time. You always define the population parameter. So P equals the true proportion of drive-through customers who have to wait more than 2 minutes to receive their food. Okay, so remember I told you a type 1 error means that we reject the null hypothesis. If we reject the null hypothesis, then we have convincing evidence. Reject, we have convincing evidence. The manager finds convincing evidence customer satisfaction was improved with the extra employee. We rejected, found this to be true. But our error is when in fact 63% of the customers wait longer than 2 minutes. Right? We made a wrong decision. This is a type 1 decision. A type 1 error, excuse me. The consequence is that manager is spending more money for an additional employee, and the customer service has not improved. Your people are not happy. Right? So when you're talking about the consequence, you want to relate it to some sort of financial consequence. A type 2 error. And one way to try to get it in your head is that when we have a type 1 error, we reject the null hypothesis. When we have a type 2 error, we fail to reject. That's a simple way of remembering that. Okay? So here, the manager does not find convincing evidence. We fail to reject. Customer service has improved with the extra employee. Okay, so we didn't have evidence, okay, convincing evidence that customer service has been improved with the extra employee. But in fact, 63% of the customers wait less than 2 minutes. Okay? The manager does not find convincing evidence customer service has improved with the extra employee. Okay? When in fact, 63% of the customers wait less than 2 minutes. Okay, so what's the problem here? Well, the manager is going to fire that additional employee because we found that there's no evidence that we need them. And we're going to upset customers with poor service. Now, which is a worse error? And that's all based on perspective. Right? So if you think a type 1 error is worse, then you lower alpha. If you think a type 2 error is worse, you increase alpha. Now, let me make a point here. The only things that you can make adjustments for when you're doing research is you can set your own alpha and you can set your sample size. You cannot control beta, type 2 error, and you cannot control power. Those are results of what you do with alpha and your sample size. So now let's go and have a little bit of a review here. Suppose that the manager decides to carry out this test using a significance level of alpha 0.10. He takes a random sample of 250 orders, and the manager found 135 customers, about 53%, who had to wait when they got to the cashier's window to receive their food. Make a graph labeling the population parameter and the rejection in the fail to rejection region. So your population parameter, in this case, is P. And we go back to our null hypothesis, and we say that P is 0.63. Right? You set the alpha. And here we have alpha is equal to 0.10. All right? And so that's our p-value. Excuse me. All right? Can't really do that because we don't know. That's kind of our line in the sand. Alpha is 0.10. Right? We don't know if our p-value is going to be on this side or this side. Right? So if our p-value, if we have a big p-value, then this is when we fail to reject H naught. Big p-value, fail to reject. If we have a small p-value, okay, then that's where we are going to reject our null hypothesis. So depending where our p-value lands, that's going to tell us whether we are going to fail to reject or reject the null hypothesis. So the question is, the probability of making a type 1 error, that's alpha. And we set alpha. That's why I always tell you that we have to set alpha, okay, ahead of time. Alpha is our willingness to make a type 1 error. And we set alpha ahead of time. You as the researcher. Okay. So, what is the p-value for this test? Well, I wanted you to take an opportunity to go back to your handy-dandy calculator and practice finding the p-value. Okay? Now, this is a proportion. Proportions means that we are going to be doing a z-test. And we have one sample. Next chapter, we are going to be doing 2 sample. So we have one sample z-test for proportions. All right. We were told the sample size was 250. Okay. They had, looks like it's a typo right here. Okay, this was a typo up here. This is 133. Okay. Here, 133 divided by 250. Okay, and let's see if we did 135 divided by 250. Okay, so 133 divided by 250 is approximately 0.53. It's actually 5.532. That is my p hat. So now I want you to go to your calculator and what you're going to want to do is that you're going to go to Stat, Tests. This is a proportion, and it's a z-test, so it's a one proportion z-test. Hit Enter. Our null hypothesis is 0.63. Okay. Our x is 133. Our sample size is 250. The null hypothesis is a less than. Okay. We're going to hit Calculate. And we found that z is equal to negative 3.21. And our p-value, the probability that z is less than negative 3.21, is essentially 0. Okay, it's basically 0. But if you want to be specific, okay, it is going to be 6, 6, and we move the decimal place over 4 places. Okay, so here is our p-value. So our alpha right here is 0.1. We can tell now that our p-value is very small. Okay, so our p-value is approximately 0 or 0.001. So that means that right here is where our p hat is. That's our evidence. And our p hat is 0.53, approximately 0.53. Okay, so small p-value, we're going to reject the null hypothesis. So I'm going to go back to my nice, neat notes. Okay, and since the p-value, or you could say approximately 0, is less than alpha equals 0.10, we reject H0. We have convincing evidence the customer wait time is less than 2 minutes. Okay? So, before I end this, I want to discuss, I'm simplifying this unit on power. It's a very difficult concept to do, and we have limited time. So usually I do a simulation using the computer, which helps you visualize what this is, what power is all about. Okay? But I'm going to cut right to the chase. What is it that you need to know about power? Okay, so power is a correct decision. Okay. So I've contacted my colleagues at through AP Statistics. We have a board, and this is what all you need to know about power. Okay. Power and alpha go in the same direction. So you increase alpha, power goes up. Power, okay, is equal to 1 minus beta. Now let me tell you this, you're never going to have to calculate alpha or beta. You're never going to have to calculate power or beta. You're always going to be given power and beta, and you may be asked to explain in context what beta is, which is a type 2 error, and what power is, a correct decision. So power is a correct decision. More and more they like you to understand that power is a conditional probability. You're rejecting the null hypothesis given the alternative. You reject the null hypothesis given that the alternative hypothesis is true. There are 3 ways to improve power. To improve power, 1, increase alpha. 2, increase the sample size. 3, have your alternative hypothesis as far away from the null hypothesis as possible. So if you have, here's your null hypothesis, and you have P or mu, the further away our sample statistic is, or our alternative hypothesis is, away from the population parameter, will increase power. Okay, there was one more that was added, is anything that reduces variability. So in your study, anything that you can do to reduce variability in your sampling techniques, reduce non-response, have better questions, that anything you can do to reduce variability will increase power. So the next part of this video is going to be to visually show you how this applet would work. Right? Some of you may just have to go to my notes that are posted on my website, and you'll understand it from those. I've tried to really simplify this to make it easy for you, because this is a topic that will be on the AP exam, I'm sure. So that ends the first part of this, and I'll see you back soon.